Okay, so we are going to start today's lesson by talking about how speed relates to velocity and acceleration. They're not the exact same thing. If I only told you about velocity and didn't tell you about acceleration, you don't really have the full picture as to what's happening with the speed. So speed is the absolute value of velocity. Okay, speed has to be positive because that's what absolute value does to a number. So whereas your velocity could be positive or it could be negative, speed is always positive. Okay, now graphically, what does this do? And so I want you to think back to when you had absolute value of f of x and you had to transform it. Remember, like shifting left, shifting right, up, down. What did absolute value of f of x do to the graph?
It made it not differential.
It reflected, yeah, you're right. It does some weird things, but it reflected negative y values across the x-axis. Okay, so it wasn't a complete reflection. And I'm going to model this for you in a couple of minutes. But it's not a complete reflection. Not everything reflects. Only what's below the x-axis reflects across the x-axis. Okay, so that's what we're going to go on as we do these problems. We're going to first look at this first situation. So this is the graph of velocity. Here's v of t, here's t. And so they give you a graph and they give you a table. And so if speed is the absolute value of velocity and velocity is 1, you take absolute value of 1, you get 1. So when the velocity is positive, the speed is just that same number. Okay. So then we're going to kind of move into this whole, is speed increasing or decreasing? And how does that relate to velocity and acceleration? And this is situation 1. I'll go ahead and tell you there are 4 situations. And we're just going to do one thing at a time. And by the end of it, I'm going to give you a very black and white rule as to how you can do these problems. But we're going to kind of figure our way through that. So in this situation, would you say the velocity is positive or negative? Positive, right? You can look at it 2 ways. You can look at these numbers. You could also say, hey, all the velocities are above the t-axis. They're all positive velocities. Okay, also, you could either look at the graph or look at these numbers, and in this case, the velocity is increasing. Now, just because the velocity is positive doesn't mean it has to be increasing. We're going to look at a situation later where these things change up, okay? So then we're going to talk about acceleration. So because velocity is increasing, remember acceleration, that's like v prime, would be which one? Positive, right? What is acceleration representing on this graph? Yeah, so physically, what would you look for? The slope. Okay, the slope. So like at the beginning, the acceleration is positive, but pretty small. And here, the slope would be bigger, so acceleration would be bigger. All right, now we're going to combine all of this, and really we don't need all of this to answer the last blank, but you can really look at any of them, although I think the table is the easiest one to look at. Would you say that speed is increasing or decreasing? Increasing. Now, this is one situation. I don't want you forming any, it's always going to be increasing when it's always like this. We're not there yet, okay? Because some of what you're assuming right now could be true, but it's probably you're assuming too much. All right, so I do want to kind of recap. Velocity was positive, acceleration was positive, and speed was increasing. All right, so then we turn the page and we look at another situation. Okay, still this is a velocity graph, but you can see that the graph looks a little bit different and the table definitely looks a little bit different. You notice these numbers are now negative. Okay, so we can go ahead and write that in here. The velocity is negative. I can look at these numbers and say, hey, those are negative numbers. I could also look at the graph and say, oh, that velocity, that's below the x or t axis, therefore velocity is negative. Okay, what about increasing or decreasing? And this is where the graph, I think, is more helpful than the table. Decreasing. You just look at, you say, oh, decreasing. It's confusing when you look at the numbers because it's hard to look at a list of negative numbers. It's like, intuition is not really your best friend here when you're trying to figure out if these numbers are increasing or decreasing. All right, and I skipped the table here for a reason, by the way. We will get to it, but so because velocity is decreasing, that's what we just decided. We know that acceleration, which is the same as v prime, is negative. Okay, remember acceleration is the slope or the derivative of velocity. Okay, so we have a situation here where velocity is negative and acceleration is negative. So do you think this is a situation where a particle is speeding up or slowing down? I'm getting some of each. So here's how we know for sure. Let's actually take absolute value of velocity. So absolute value of -1 would be 1. Absolute value of -2 would be 2, and so on. So last time these numbers didn't change because taking absolute value of a positive doesn't change it. Here they are changing. So let's just think about the speed here. From 1 to 16, the speed is increasing. This thing is speeding up. This is not intuitive to most people. All right, if you look at this and you see all these negatives and decreasing, you might think slowing down. This thing is speeding up. It's just speeding up in the opposite direction. Okay?
Is this a rule, like the sign of the velocity and the acceleration, if you multiply negative, you get positive, and then on here it's positive, negative, positive.
Okay, I'm going to simplify what you just said. The signs of velocity and acceleration, the fact that they were both positive and now they're both negative, definitely those are related to each other and giving us that the speed is increasing. Let's do 2 more situations and then yeah, you may come back to, you may want to modify what you said just a little bit. Okay, so now we look at situation 3. So I want you to try to do this one on your own, and you can start with the table here, you can start with the blanks. Okay, so hopefully you filled in all of this. So we already know that last blank is going to be decreasing. But let's see like why. Okay, in this situation the velocity was negative. You can see that from the table or from the fact that these values for velocity are below the x-axis and increasing. So you can have any combination of positive and negative, increasing, decreasing here. Okay, we've seen now 3 different combinations. So because that velocity was increasing, we know that acceleration is positive. In other words, we have a negative velocity and a positive acceleration. So we just got through doing 2 situations where both were negative and both were positive, and now we have where only one of them is negative, and that caused a decreasing speed or slowing down. Okay, I'm going to go ahead on this one and kind of model the graph of speed would look like this. All these negative y values would be reflected across. This is not something you're going to have to do. This is something, though, that may add a layer of something that helps you understand it. I don't know. If you're like, nope, it doesn't, then you don't need to draw that. It's okay. Okay. So last one, I want you to try to do this one on your own. And go ahead and there on the conclusion below it, go ahead and try as much of that as you can. Okay, what'd you guys get for velocity? Positive or negative? Positive and decreasing. And then so because velocity is decreasing, acceleration is negative. So we have a positive velocity and a negative acceleration and a decreasing speed. These numbers are decreasing. So the thing is, have you picked up on the rule? Some of you have a little bit. Let's just kind of tighten that up. So in which situations was the speed increasing? 1 and 2. 1 was where both positive, 2 both negative. Okay, so they had the same signs. Velocity and acceleration had the same signs. Okay, and another phrase we could use for speed is increasing, we could say speeding up. Okay, in what situations was speed decreasing? This would be 3 and 4. And in one of these situations, the velocity was negative, but the acceleration was positive, and in the other situation, it was the opposite. Either way, one positive and one negative, they had opposite signs, and that caused speed to be decreasing, which we could also phrase that as slowing down. When velocity is negative, this doesn't become as intuitive as when velocity is positive. Okay, so this is a good way to kind of fall back on this, and also this is a good way to explain your answer. All right, you guys ready for a quiz over this? Okay, turn the page. Y'all think I'm kidding, but you get to grade your own, so it's okay. So turn the page, and you're going to go ahead and take a quiz. I'm going to give you 2 minutes. Okay, ready to grade?
Let's do it.
All right, if velocity is negative and acceleration is positive, then speed is decreasing. Why?
Opposite sign.
Opposite signs. That would be your, like if we had to write a because, it would be because velocity and acceleration have opposite signs. Okay, here we have velocity is positive, but then they kind of switch it around. They say speed is decreasing, which means that we have opposite signs. So then acceleration must be negative. All right, velocity is positive, and if velocity is decreasing, then what does that tell us about acceleration? If
It's also decreasing.
it's negative. So if velocity is decreasing, that means acceleration is negative. Opposite signs means speed is decreasing. It's all about, does velocity and acceleration have the same sign or opposite signs? That's what it comes back to every single question. Speed is increasing, so same sign. Acceleration is negative, so velocity would be negative. Same sign, because it said speed is increasing. Okay, velocity negative and increasing, which means acceleration is positive. Opposite signs, so speed is decreasing. And 6 kind of throws you for a loop if you don't catch it. When it says the particle is moving to the left, what is that telling us about velocity? Negative. And it says speed is decreasing, opposite signs, so acceleration must be positive. How'd you guys do? Good. So these are not really test questions. These are more like really making your brain work sideways, forwards, backwards to get the concept. Okay, if that wasn't enough, we're going to look at this one more way that for some of you that keep getting mixed up, what I'm about to show you may be helpful. Okay, so there's some stuff there. You can definitely read it. This is a velocity graph. All right. Up here, above the x-axis is where the velocity is positive. Down below is where the velocity is negative, since this is the graph of velocity. Now, if I want to determine acceleration, what am I physically looking at on the graph? The slope. So in this first section of line, acceleration is negative. So all the way down from the beginning to where t equals 4, that slope is negative, therefore acceleration is negative. And then after 4, we have an increasing graph, or the slope, the acceleration is positive. So those are your 4 scenarios right there on the same graph. The 2 with the same sign is a speeding up. And I'm going to explain this a slightly different way that really only works on a graph. if you imagine this particle traveling, okay, as time goes on, the line almost kind of, the line represents stopping, basically. Okay, when the particle is on the t or x-axis, it has stopped. So the particle's slowing down, stops, and then as the particle moves away from the t or x-axis, that's when it's speeding up. So moving away, speeding up. Moving towards the line, slowing down. Moving away from the line, speeding up. This only works when you're given the velocity graph, although good news is that's the graph you're given most of the time. Almost all the time. Okay, and there's some other stuff there you can read. Okay, yeah.
Quick question. If you're speeding up when you're moving away, why is acceleration negative?
Because you're speeding up, like your acceleration, like velocity, implies direction. So it's not intuitive to think a negative acceleration means velocity is decreasing, but it doesn't mean speed is decreasing.
Okay.
That's where, this is why we kind of come back to this whole, does velocity and acceleration have the same sign or opposite signs? Because this situation right here is not super intuitive. Like you want to think this is a slowing down part,
Okay.
but it's a speeding up in the opposite direction. Okay, so let's now go back and look at the page, if I can find it, here we go, that we left off with yesterday. Okay, so I just want to kind of remind you, I'm going to change the zoom here. Okay, I want to remind you of this problem that we did yesterday, and this is on page 4, I believe. So we started off with a position equation, and we were asked about moving to the left or to the right, so we had to find velocity. All right, we evaluated the velocity. We did that problem. Then it talked about, is the velocity increasing or decreasing? That was then when we found acceleration, and we went on. And then the last thing that we talked about yesterday was find all the values for t for which the particle is moving to the left. So then we had to take our velocity, set it equal to 0, and do a sign chart. Okay, and that was the last thing that we did. All right, now you have some handwritten problems on your paper, and I'm going to have to write them on here. So here's the question. What is the furthest distance? I can talk a lot faster than I can write. The furthest distance to the right that the particle travels. Now, I have left off some information that's actually you need. Anybody know what that is?
Oh, is it closed interval?
Yeah, we need a closed interval. We need to have a stopping time, because otherwise it's just going to keep traveling to the right forever and ever and ever. So what I should have said was on like 0 to 3. Okay, so go ahead and add that in. And so in thinking back to what we did here, we can actually disregard everything after 3. And I'm using this sign chart just because we already did it. It gives us a pretty good idea of what's happening. At 0, from 0 to 1, particles moving to the right, and at 1, it changes direction and moves to the left. So that doesn't tell me what the furthest distance is, but it does tell me when this is happening. So what's the time when the particle is furthest to the right?
0, 1.
Yeah, t equals 1. Okay, at 0, the particle is wherever it is. It moves to the right. And at 1, it changes direction and moves to the left. So at t equals 1, that's when the particle is furthest to the right. Well, how am I going to find what that position actually is? Yeah, we plug it back into the position function, okay, which is right up there at the top. So we go x of, not t, x of 1. And you can use your calculator here, although this is really not a terrible one to do without. And you get 15. And there are no units here, so we'll just call it 15. I didn't use the word max or absolute max, but that's what I did. Okay, what I could have done, if I had not already done this sign chart, I could have plugged 0, 1, and 3 back into the position function and seen which one was the biggest. But since I had already had an idea of what was going on with this problem, I didn't need to do that. Okay, while I write down your number 5, I want you to read it and see if you can have an idea of how you can do it. Okay, so here I flat out tell you, we're doing max and min. Okay, and this is implied absolute max and min velocity. And so I don't have a sign chart, and I'm not going to do one. That really only works for relatives, which could be the absolute. But with absolute max and min, I don't know why I wrote x, that should be t. We need to do a chart. We need to do a t chart like this. And what we need to do is figure out what t value gives me the biggest velocity. You do not need to just plug in any number until you find the biggest number. This was on the last test, and a lot of people missed this. They weren't quite sure what numbers to put here, and they weren't quite sure where to plug them in. So 2 of your candidates are right there in your closed interval. Anytime you start and stop, that could give you your maximum position. It could give you your maximum acceleration or velocity or anything. I'm not saying it is. It's just a possibility. Okay? Now, the other number or numbers that go here are possible relative maxes and mins. Okay? So what you do is you look at what you're trying to maximize and minimize. It's velocity. Okay, that's why I wrote velocity right here. I want to know where that thing's derivative is equal to 0. Okay, do we have anywhere on here where we've already found velocity's derivative?
Yes.
Yep, right here. 6t minus 12. So we need to solve that. 6t minus 12 equals 0, t equals 2. That's another candidate. If v prime equals 0 at 2, that could be a relative max, it could be a relative min, and therefore it could be an absolute max or min. I don't need to test anything else. Testing anything else would be a waste of time. If there's a biggest number, it's going to be the outcome of one of these 3. Same with the smaller number. All the other numbers are going to be in between. And so we need to plug this into actual velocity. Okay, so like go up until you can see the velocity equation. And so if I plug 0 in, what do I get? 9. So that's what I have right now. I'm looking for something bigger or smaller than that. Okay, what do you get when you plug 3 in? And you may want to use a calculator for this. This is why I had you get your calculators out. Or you might actually, it is 0. This was one of, we actually already found out where the velocity is 0, and so you could have noticed that, or you could just plug 3 in. And then what do you get when you plug 2 in? -3. Now you have a calculator, you can do those calculations, and I encourage you to do that. The reason some of people miss this on the test is because they didn't know where to plug it in. Here's how an easy way to know is, what are you trying to find the max and min of? Velocity. So that's what you plug it into. You plug it into what you're trying to maximize and minimize. The biggest number is your max, the smallest number is your min. There's no units here, so we won't worry about the rest of that. Okay, I wrote those in because I felt like from last year and the year before, I wanted to do more practice on this type. That's why I wrote it in kind of last minute. Okay, I want to do one more example. Keep your calculators handy. We're going to skip. I want you to skip all the way to page 11. Because on your worksheet there's some calculator problems, and we need to practice the calculator a little bit. I need to pull that up. All right. So, and the ones that I don't get to today, we'll go over tomorrow. So it says the rate of change in kilometers per hour of the altitude of a hot air balloon is given by this equation. T is measured in hours, assuming the balloon is initially at ground level. Okay, here's the words I did not hear. Position, velocity, and acceleration. I didn't hear any of those words. We have to figure out what's implied. Okay, altitude would be like your position. Is this equation right here representing altitude or position? I don't mean one or the other. I mean, altitude and position are the same thing. So this is a yes or no question.
Yeah.
Is RFT representing the altitude? Okay, I want you to go back to the beginning of that sentence and read it again. The rate of change of the altitude is given by RFT. What is RFT representing? It's not representing altitude. It's representing the rate of change of altitude. So it's like velocity. Exactly. In other words, if we had an A of t, I hate using A because it's acceleration. If we had an altitude that was x of t, then x prime of t would equal r of t. Basically, this is the derivative already. It is the first derivative. You had two indicators. You had the phrase rate of change. You also had this nifty kilometers per hour. But if you didn't read that part, you just saw altitude given by, and then you get all the rest of this whole problem wrong. So that's kind of tricky, but we got to practice it. Okay, so for what values of t in the closed interval 0 to 4 is the altitude decreasing? So if I want to know where the altitude is decreasing, I want to know where r is negative. I don't need to take this thing's derivative. It already is the derivative of the altitude. Okay, so it would just be t cubed minus 4t squared plus 6. First of all, let's see where it equals 0, and then we'll do a sign chart to figure out the rest. This is where you're going to need the calculator. You can't do this without the calculator. So just a quick reminder, I'm going to clear the home. I'm going to clear any variables just to make sure everything's good to go, and then I'm going to solve. So I'm going to do F2 algebra. I'm going to solve, and then I'm going to type this in. You can use t or x, by the way. It doesn't matter. If you use t, though, just make sure you stay consistent. Okay, make sure that you have your equals 0 in there, and make sure you do comma, in this case, comma t. If you don't have your calculator today, or if the batteries are just dead, make sure you get that taken care of and bring it tomorrow and the next day, especially because we have a quiz Thursday. You want to have a calculator. You're going to have to do these calculations by hand if you don't have a calculator. Okay, it's going to take a second for it to calculate, and these numbers are super messy. Okay, and yours may come up in a different order than mine. And I get 3 answers. Could I have predicted that I could get 3 answers from a cubic? Yeah. All right, so I'm going to write down the answers in order, ascending order. Those of you that don't have a calculator and you're just like kind of watching this, I want you to think about which answer have I written up here that does not make sense. So what do you guys think? Which time makes no sense? The negative one. So we didn't even have to write that down. It also, if I had had a time that was greater than 4, I wouldn't include it either. So I only want to include the times between 0 and 4. So these are the places where the rate of change is 0, where the balloon is either increasing or decreasing, like changing from increasing to decreasing. So what we want to do is we want to go ahead and make a sign chart. Now there is a way out of this when you get to use your calculator, but I'm going to go with what we know and what we are pretty good at. Notice at the end caps, I'm writing 0 and 4, not negative infinity to infinity. Also notice that down here I'm going to write R of t, and up here I'm going to write altitude instead of f prime and f. You can really write whatever you want though. This is really just your work. So again, you can use your calculator to test these 3 things. Now, I did have 3 root cubic, so none of these are double. So whatever you get here, it should be opposite and it should flip-flop. It should go positive, negative, positive, negative. It shouldn't have 2 pluses next to each other. So if you plug 1 in, we get 1 minus 4 plus 6. That's positive, so altitude is increasing on this interval. And this is what I was saying. This is a well-behaved function, so I know that the next one should be negative and the next one should be positive. If you want to be sure though, be sure. Plug it in. So back to the question, what are the values of t where this balloon is, the altitude is decreasing? We would say 1.572 to 3.514. If you don't like doing all of this with your calculator, you could have actually graphed the velocity and figured out where it was above the x-axis or below. We're going to talk more about how to use our calculator efficiently, like in these types of problems, later this week. But this is, you have knowledge. You don't have to do it that way. Okay, so let's do the second one. Find the value of r prime of 2. So that means we got to find r prime of t. That's just a simple derivative. And we got to evaluate it at 2. And you should get negative 4. So now we need to explain the meaning. So if r is the rate of change, what is r prime representing? The acceleration. We could say, we could use that word. We could say the rate of change of the rate of change. That's a little, that's not very smooth. Here's probably the best way to explain this. The rate of change of the altitude at t equals 2, and this is in hours, is, okay, now this is representing r. This is r prime, so we got to say increasing or decreasing. Which one should I use? Decreasing, because of the negative. So decreasing at a rate of 4. Notice I didn't put negative 4. If I already say decreasing, I can't also put the negative. That's a double negative. That isn't what I mean. Now I just need to put units, and I'm good to go. So this is going to be kilometers per hour is r. So if r prime, I would just do r hour squared, like how I do for acceleration. Okay, that's the best way to write this. There are other things that are acceptable. Okay, and we got one more part, and I need to write it here. So I want you to read what's already on your paper and think about how could you do that last part. And I really should have put the closed interval, although it is in there. Okay, what are we trying to maximize and minimize? Acceleration, right? Do we have an expression for acceleration yet? Yeah, we just did it. It's right here. Draw yourself a little arrow if you need to. I know 0 and 4 are two candidates. And I put an X there. Anybody notice that? What's the other? Thank you. What's the other candidate? Do I set this thing equal to 0? I mean, this is the acceleration. I need to figure out where A prime is equal to 0. So what would A prime be? It would be 6t minus 8. I know I'm going through this part pretty quickly. I'll probably go back over it tomorrow. But 4/3 is your other candidate. Whatever you're trying to maximize or minimize, that thing's derivative equaling to 0 is how you find your other candidate. Although I'm not plugging it into that thing's derivative, because I'll just get 0. I'm plugging it into that thing that I'm trying to maximize or minimize. All right, I'm going to give you these numbers, and we are going to go over this again. But your maximum is going to be 16 kilometers per hour squared, and your minimum is going to be negative 16/3 kilometers per hour squared.